I am Dr. Ravi. In this learning dialogue, today we deal about the force and its effects, which is a part of Introduction to Engineering Mechanics course. The mechanics is a science which deals with the physical state of rest or motion of the body when acted by forces. And now we are into rigid body mechanics, so that we shall understand what is a rigid body and the effects of force. A body is said to be rigid when it does not undergo deform by the application of forces. Or simply we can say that if any two particles on a rigid body remains unchanged, the distance between the two particles remains unchanged, then we say that the body is rigid. And just pause the video and answer the reflection question. Does a true rigid body exist in nature? Please pause the video and answer this reflection question. So you have imagined the answer. Now let us understand what happens in nature. In nature, a rigid body may not exist. The reason: so any body cannot resist deformation with the action of large force. So suppose if we take a body and keep on increasing the force, at some point the body starts deforming. So in nature we can understand that a real rigid body does not exist. But under certain conditions, under certain loading conditions, we can say that the body is rigid. And now let us come into the force and understand what is a force and its characteristics and its effects on the rigid body. A force is an action of one body over another body. It can be in the form of a push or a pull. It can also be defined as an agency which changes or tends to change the position of rest or motion of a body. If I try to understand the characteristics of a force has magnitude and direction. And it tends to move the body in the direction of in its direction, or it may also rotate the body. And another important characteristic is line of action of a force and the point of application of a force. So a force is characterized by magnitude, direction, line of action, and point of application. And obviously it is a vector quantity since it has both magnitude and direction. Now let us see a force F acting on a rigid body. So initially it is acting at A. So the black line shows the line of action of the force. And then I have moved the force to a new point along this line of action to B. Now pause the video and answer the reflection question. Does the effect of the force remain same irrespective of the point of applications A and B? Just imagine and answer this question. Hope you came back. And now let us understand what happens. So the effect of the force remains same irrespective of the point of application along its line of action as per the law of transmissibility of a force. So now the effect of a force on the rigid body when it is acting at A or B will remain same. Okay, so this could be useful in further solving the problems of resultant. Now let us understand the types of forces. So basically they are classified as contact forces and non-contact type forces. So contact forces is applied force, like as we have seen in this case, force F is an applied force. Tension force, suppose if I pull a string, so I'm applying a tension force on the string. Spring force, frictional force, normal reaction, air resistance force. So these are the forces which exist between contact bodies. So non-contact forces, gravitational force, electrical force and magnetic force. So these are non-contact forces. So gravitational force, when a body placed on a table undergoes a gravitational force, we all know. So such forces are non-contact forces. Let us see how a force is represented. As a force is a vector quantity, it needs to be represented by both magnitude and direction. And units of a force is Newton. So 1 Newton force, 1 Newton is a force required to accelerate a body of 1 kg mass to an acceleration of 1 meter per second square. Now in order to define a force, we need to describe the magnitude, direction and its line of action. So in a simple sense we can say a force F of 10 newtons is acting towards right in the upward direction at an angle 40 degrees with the horizontal. We also understand how to represent a force in the vector form. Here let us see a force F of 10 Newton acting along the line AB, where the coordinates of A are x, A, y, A and the coordinates of B are x, B, y, B. Now the force F in the vector form can be represented as the product of force, magnitude of the force, and the unit vector representing the direction. So now if we make an attempt to write the unit vector as the force F is acting from AB, now we can finally say that force vector F bar is equal to product of magnitude 10 newtons into unit vector of AB. Let us see how to write the unit vector of AB. So unit vector of AB is equal to AB bar by mod AB bar. This is vector AB bar by magnitude of AB bar. Now we can write AB bar is equal to xb minus the coordinate of x coordinate of b minus x coordinate of a into I bar plus yb minus ya into z bar. And mod AB bar can be written as nothing d is root over xb minus xa whole square plus yb minus ya whole square. So finally unit vector AB bar is equal to xb minus xa into I bar plus yb minus ya into j bar by root over xb minus xa whole square plus yb minus ya whole square. Now finally the force F written in vector form as 10 into xb minus xa into I plus yb minus ya into j by root over xb minus xa whole square plus yb minus ya whole square newtons. So a force can be represented in a vector form or by its magnitude and line of action. So after this learning dialogue, please go and practice learning by doing activity 1 in order to understand more about the force and its effects. Thank you.